Hello, and thank you for joining the presentation. I'm Hakkim, and I'm heading up Zalando's reference apps organization. So if you download the app, roughly 60% of the customer journeys that you can experience in the app are built by my teams. But underpinning all of that, my teams are also responsible for building the apps platform on top of which all customer journeys are built. So today's agenda, I'll start off by giving you an overview of the Zalando apps landscape. Then I'll talk about what developer productivity is and why more and more companies are investing into boosting their productivity practices. Afterwards, I'll give you an introduction into some research models that theorize about how to practically improve developer productivity. Then with all of that theory out of the way, we can talk a bit about kind of practically applying that at Zalando. So it's also kind of one of our core tenets that we don't try to reinvent the wheel. So I'm gonna try to, as much as possible, cross-reference the practices that we are inducting into those that are being adopted by large companies like Google, Netflix, Meta, etc. And finally, will look at how we executed on all of that theory by looking into our portfolio investments for 2023 and looking ahead to 2024. Also, where possible, I've kind of added snapshots for original materials like research papers, slide decks, etc., and in order to preserve fidelity. I don't know if you get the slide deck with this, but I've linked to a Medium article where you can find the full the full text of what I'm of this presentation. Good. So looking very quickly at the Zalando app landscape, we have just over 70 million installs on Android and about the same for iOS. Our annualized app visiting customer base grew by about 40%, and it's been doing that since 2018. The number of app visits grew by more than 4 times as compared to web. And I think this it's kind of in line with the trends that we're seeing in the industry where organizations are increasingly investing into mobile first engineering or product development. Okay, so let's dive into the why and the what of developer productivity engineering. So Jonathan Carter is the technical advisor to GitHub CEO, and there's this interesting anecdote that apparently he used to hate vacuuming. And turns out the reason is because he kept his vacuum on the first floor, and bringing it downstairs was quite tedious. And when he realized that, he apparently, you know, kept the vacuum downstairs, and the task turned out to be a lot more easier. And apparently now he vacuums every other day. I don't know how much truth there is to this anecdote, but I think it's a useful analogy uh, to kind of create clarity around the distinction between the quality of a tool and the qualitative experience of using the tool. So what is developer productivity management experience? So depending on who you speak to, there's kind of all sorts of nuances around these different terms. I'm going to kind of just refer to them interchangeably to refer to the practice that places a developer at the center and looks at her ecosystem, right? So, and by that I mean the infrastructure, the tools, the processes, and asks how these are contributing towards her productivity, her overall job satisfaction, and also her operational output or impact. So why is DevX important? As we all know, I think, and as Greg Mondello, the director of product at GitHub, points out, in most scenarios, the limiting factor for innovation is development capacity, right? So if you have 1,000 engineers, of course, you're going to innovate a lot more than if you had just 10. companies doubling down on productivity, at least in the long run, you know, they're going to have a competitive edge in terms of being able to innovate faster. And in today's world of disruptors, that could, of course, mean the difference between success or failures of companies. So that brings us to our favorite question at Zalando, which is how do you measure success? And broadly speaking, there are two me-see categories of success. I'll come back to this term a little bit later. So we have sort of tangible, measurable factors, right, that can produce consistent results. And things, so here I'm referring to things like lines of code, DORA metrics, test fakeness, etc. And these are objective metrics, right? Developer surveys, on the other hand, are a bit more psychometric in nature, and they're more referring to subjective factors, right? So these are the so-called subjective metrics. A quick diversion on the topic of metrics and giving how much importance you give to them. So Goodhart's law states that when a measure becomes a target, it ceases to be a good measure, right? And there's truth to that. I mean, so if you take lines of code and you're trying to optimize for lines of code, you know, you just have to write really verbose code, right? Or in the worst case, if you just copy paste methods instead of reusing them, right? You're gonna improve your lines of code, right? So, but we know that both of these tactics are completely useless and counterproductive to what you're trying to achieve. At the same time, subjective measures also suffer from cognitive bias, right? So personal bias. So, you know, I had a bad interaction with the client, so I'm more likely to score collaboration lower if I get the survey today, right? So I think the lesson here is that you don't want to use these metrics to police people, right? So these are more about um, kind of enabling people, and that's how the more prominent organizations are utilizing these metrics. Okay, so now that we understand the components of DevX, let's dive into the canonical models that I talked about earlier. So all of you probably know this term now. So the Google DevOps Research and Assessment Team, or the DORA team. So since 2013, they've been conducting these large-scale surveys, and their aim is to try to understand statistical links between different development factors and business productivity. In 2014, they published their first State of DevOps report. And since then, they've kind of been doing this every year. And they asked the following questions in the survey. So the first two focused on deployment frequency and lead time for changes. So this is about how fast you are developing or deploying code, or rather getting code into production. Doing things fast is important, but that's also just one half of the story, right? You also want to make sure that you're careful and not breaking things as you're moving fast. And that's where the second two question comes into play, which is MTTR, as mean time to restore, and change failure rate. So these two speak to the stability of your deployments and releases. And they made these findings kind of public in their famous book, Accelerate, which established DORA metrics as a household name in developer productivity. And I must say the important thing in the slide is that this team, looking at the data, they consistently found that there's strong statistical links between software delivery performance and the business performance. So they postulated that these things are causally linked. Okay, but so that's DORA, and now post-DORA. So in 2021, one of the authors of the Accelerate book, they did some research with Microsoft, and they produced what is called the space model. And here they claim that the developer productivity is not just about the efficiency of software delivery, but it's also dependent on effective components. That is how people perceive the quality of their work and the quality of their engineering. The theory was that there are certain pervasive harmful myths, right? And that if we don't address them, uh, you, yeah, we're not going to have the best performance, right? So in order to optimize performance, we need to be able to put countermeasures in place in order to address these myths. The one I want to call out is the last one, which says productivity is only about engineering system and developer tools, right? So this really is the essence of their ideology. So this table gives a kind of an overview of the space framework and the KPIs associated with these dimensions. So on top we have so on top of performance, we also have things like communication and collaboration, efficiency and flow. And you can see that they've spread it across not just the individual, but also the team and the system. So this is a great step because we are starting to bring the developer into the fold, right? But 2 years later, in March 2023, some of the members from the space team that produced the space research then produced another paper, this time called DevX, postulating that, okay, well, if you really want to improve developer productivity, what you really need to be focusing on is developer experience. And in the new model, so there's 3 dimensions. So you have feedback loops, which is kind of about the delivery performance, right? The quicker lead times, the sooner you have feedback loops from customers. You have cognitive load on the other side, and then you have flow state. I'll come back to these shortly. So I'm also not going to go into too much detail about either space or DevX. I kind of more wanted to give you sort of a very high level overview of how prominent people are thinking about developer productivity, and also to get a sense of how fast the field is evolving. Okay, so now let's discuss Zalando's approach to boosting developer productivity. So we believe that any kind of theoretical model should have a strong foundation based on sound principles, right? And one such principle that really resonated with us was the MISI principle, which was developed by Barbara Pinto at McKinsey, who I think many of you will also know as the author of the pyramid principle, Logic in Writing and Thinking. So this is a categorization framework, right? And the idea here is that there's 2 categorization rules. So when you're creating categories, you want to select categories in a way that each of these different types are mutually exclusive, right? So that means that any item can only belong to one of these categories. And the second rule is that all of these categories should be collectively exhaustive. So in a sense, any data point can only belong to one category. So it must belong to one category is the first rule, and it can only belong to one category. Sorry, the other way around. Okay, so, and as an example of the MISI principle applied, so grouping customers by age is a good MISI categorization example, right? So what we have is every customer is going to fall into one age bracket, right? So that means that it's mutually exclusive, and it's collectively exhaustive because they have to fall into one of these buckets. So there are a lot of developer productivity models, like I explained before, but what we really tried to do was to find that one that sort of satisfied the MEC principle. And the one that resonated most with our needs was the one developed by Swarmia, who, if you don't know, are a company that's specializing in creating build tooling or productivity tooling. And to give a mental model of the approach, the DPE components can be viewed as kind of this black box product factory, right? So you have the infrastructure. Well, let me start from the top. So you have the feature specifications that's going into the system, and as an outcome comes products and actual features, right? And of course, these feature specifications, they should ideally derive from your business strategy that is then cascaded down through your operational plan uh, and eventually into a team's roadmap and their backlog, right? So these inputs flow into the into this black box, which is what we refer to as the infrastructure, and this kind of encompasses everything that is tied to the product machine, right? The engineering machine, and by that I mean things like, you know, the processes, the tools, the infrastructure that is actually used to build these products. So a third dimension that Swarmia also considers is the affective dimension, right? So this is about how the developer feels about their productivity process. So to, you know, this is a bit more of an expanded version of the black box. So you can see the infrastructure part, right? So that's the black box. And you can see it's composed of things like the dev tools, the libraries, the processes, etc. The inputs flowing in and out are grouped under this value of work bucket. And here we're talking about the business goals that we're trying to achieve by developing these various customer journeys, and how well aligned and communicated they are to the engineering teams, well, to the product teams, I should rather say. And the third, as I mentioned, is the affective dimension, which is about the feelings about work, right? And here we're talking about things like respect, belonging, etc. Okay, so let's put this model into practice. So how do we actually then drive great DevX? Based on sort of our model of productivity factors, it should be quite simple, right? So we have these three different components, and the idea is that we try to optimize for each of them. So firstly, we want to enable better infrastructure by reducing infrastructure friction, right? And here I'm really talking about avoidable friction, which I'll come back to in a moment. We want to improve the value of the work, and we want to do this by creating customer value in a sustainable way, right? And finally, we want to kind of enable this flow state, which is highly correlated. It's the most significant impacting factor on improving feelings of this affective dimension. So we can now deep dive into each of these. So starting off with infrastructure friction. So the most impactful root causes of infrastructure friction are slow builds, right? I think all of you know this by now. IDE experience, slow IDE experience, and finally slow infrastructure setup, right? So starting off with slow builds, so we did this internal builder-facing survey, and we found that waiting for long builds turned out to be by and far the biggest source of friction. And we say that primarily because it isn't uncommon for developers to build in the hundreds of times per day sometimes, right? So as an analogy to drive this home, waiting for bills is kind of like waiting at a traffic light, right? You're not there really long, but you absolutely hate being there, right? And this is, I guess it has to do with human psychology. We don't like waiting. So if you come from a non-app world, you're probably wondering, like, what's the big deal with builds? We have really fast builds, right? So just to expand on that a little bit, so this has to do with the impact of modularity on apps. Whereas in the backend, you have these, you're able to decompose your application into small isolated components that you can deploy individually. In apps, you generally have, you know, multiple teams that are working together to build a single binary, which you then launch with, you submit to a third-party app store, and then they then, approve it. After which you can roll out to your customers. So what do you do about it? And I think the obvious answer is, of course, we can try to modularize it, right? So if you have this large monolith, anytime someone changes the code, the compiler is going to have to rebuild the entire monolith, right? What you can then do is you can kind of try to break up this giant monolith into modules so that when there's a change in a particular module, you can use tooling to keep track of the dependencies and then only build the dependency tree that has been changed. So we are seeing a lot of, as trends, we're seeing a lot of large companies invest quite heavily into modularization. And many of these companies, what they do is, in order to gain efficiencies by unifying processes into a single repository, or what we call a monorepo. And Google, for example, is a good example of this. But some companies also just choose to have a repo per project, right? So Microsoft and Netflix are quite famous for doing this as just individual repos. Okay, great. So, you've broken this giant monolith into modules, but what you're going to find is then a different kind of problem shows up over time, because now you have this kind of explosion or proliferation of modules, right? So this is from Uber, and they have 12,000 modules, right, that need to be all managed. So, and just to kind of drive the point really home, if you look at the number of build targets, typically in backend system, you have a handful of targets, whereas for the Uber app that we just talked about, across 12,000 modules, they have over 150 different targets. Okay, so that was a bit about modularization, and now, so this is the challenge, right? So now you've got this crazy number of modules. What do you do about it? And the answer to this is that people are investing heavily into build engineering optimizations. So as an example, so typically build engineering optimizations, they take the form of migrating to more sophisticated build tooling, right? An example here is from Apple Siri, who over the period of a year migrated from Maven to Gradle. And these tools, what they do is they typically run in the background, right? And they kind of monitor your file system. They monitor your code files, and they watch out for changes. And the moment you change something, they also track and keep a dependency tree. And additionally, they also, after your first build, they tend to cache your builds. So the Siri team particularly call out 2 points or 2 components that have drastically improved their performance. The first is the Gradle daemon, which I talked about more or less as the fundamental component of these type of systems. And the other is test parallelization. So we'll talk about test parallelization in a little bit. they published these results, and what the outcome of all of this was that they saved 11 minutes. Now, across 350 people, team strong, that translates to 16,500 developer hours over the course of a year. Okay, so one of the benefits of migrating to the sophisticated tooling is that they can generate all kinds of useful logs, right? And the onus then falls to the builder teams, the platform teams, to actually utilize these logs and to derive useful insights from them. And typical use cases for these are to enable engineers to sort of debug logs faster, so debug their builds faster, typically through some sort of self-service mechanism. And the second is for the 24/7 incident response teams to be able to react quickly to these two potential incidents. So the result is, they large companies are investing into their own form of observability systems. So here again is an example from Uber of their local developer analytics system, the so-called, or LDA system. And what you can see is, they're mining a lot of data from local machines, and they're kind of pushing that up to a central store, and then deriving a lot of insights and creating dashboarding around it. Of course, in the EU, this is a little bit harder to do because of our GDPR restrictions. But nevertheless, I think your CI/CD pipelines are still general enough that you can mine data from your pipelines. Okay, so again, another problem when you have a ton of modules and as the complexity of your code base grows is that your IDEs start to get slower, right? So things like pulling down a new branch, right? Doing your builds, your setups, they're really expensive, right? So another trend that we're seeing in the industry are that a lot of players are adopting cloud IDEs. So this is an example from Airbnb. And their promise is, keep your laptop code free. What they've essentially done is, so from JetBrains, we have this remote development. I don't know if you all heard of JetBrains Gateway. So the Android Studio, which is the most prominent IDE used to build Android apps, it's built on top of JetBrains, of IntelliJ, which is from JetBrains. And they've separated the IntelliJ engine and they've put this in a remote machine, right? Or they've created the capability to put the engine in a different remote machine. And then you just have a very thin client that you're interfacing with in your local machine that's just communicating to the remote server. So this is really exciting, right? That means that you can spin up a machine on AWS or GCP depending on your needs, right? So if you're going to be doing a performance-intensive type of workload, you can spin up a compute-intensive resource. And likewise, if you're going to be doing a lot of database queries with cross joins, you need to keep a lot of memory, a lot of data in your memory. You can spin up a memory-intensive cloud resource. So putting all of these together, right? So how do you reduce infrastructure friction? So investing into modularization and then effectively dealing with sort of the side effects of successful modularization. And then, of course, employing sort of remote IDE-like tooling to boost or to speed up your setup times. Okay, so we covered the black box, right? So that was the infrastructure part, the engineering or product machine, however you want to call it. Then we want to talk. So the next component is the inputs and outputs from the system, and this is about how do you create customer value in a sustainable way. So one of the sort of worrying trends is that we're seeing a lot of managers not investing enough into tech debt. And they tend to justify this by saying, hey, we can always throw people if we really need to when a project is late. But reality is that we know from Brooks' law that the later a project gets, throwing more people into it after a certain point actually only slows the project down, right? And this is typically because of ramp up time. You got to onboard the new engineers. Also because of as you add more people to your project, there's more connections, right? So it becomes kind of this combinatorial problem, right? You got more and more combinations of people to communicate and align across. And the last is, unlike sort of mechanical work, software work packages are not that easily divisible, right? Good. So as I mentioned, uh, the worrying trend is that a lot of people are not investing enough into tech debt. Um, And in a large, possibly the largest survey done of its kind, what was found was that 40% of developer time is actually spent on managing tech debt, right? On coping with tech debt. However, only 10% of managers said that they're actively investing into tech debt, right? So this is really a large discrepancy that we see in the industry. So of course, it's important to create customer value, right? Your business exists because of your customers, so of course there's that. But it's also equally important to perhaps do it in a sustainable way, right? So I'll come to this in a little bit, but Dropbox has this interesting sort of portfolio categorization framework, and this is from them. But you can see, unless you have a good diversified portfolio of the different types of workloads, you're gonna end up spending a lot of time just dealing with a lot of tech debt, right? So again, to dive into the solution a little bit more, you could utilize something like Dropbox's investment buckets framework. So they popularized this framework, and what they do is they just very simply bucket their work into 4 categories. Okay, so you're either building new things, you're improving stuff, you're improving developer productivity, or you're keeping the lights on. Right. So this is things like, when there's a GDPR law change, like consent management. This is about, or your routine annual operating system upgrades. This is what we mean by keeping the lights on. So categorizing the work, it really allows you to create visibility into your tech debt, right? What we found is that it's not so much that executive decision makers don't want to invest into tech debt. It's more that they don't have sufficient transparency into tech debt and what sort of impact it could have in the long run. So what we tried to do was we tried to kind of upfront create this alignment with stakeholders and to agree to some sort of a fixed amount of work, right? Fixed capacity that we can always invest into managing tech debt. So, and of course, the aim of this is that we're trying to minimize firefighting in the long run. We know from personal experience from surveys, internal surveys, and also from research, that being in this constant kind of firefighting mode, just keeping the lights on, you're going to have trouble, you're going to burn people out. And what we did, and I think this is a good start for many companies, is to negotiate something like a 10% payback on an ongoing basis for reducing tech debt. Okay, so on the theme of borrowing from developer productivity research, the third thing that you can really do is you can try to enable flow state. So this comes from a book by, I forget, I'm not sure if I have the person's name, but the term was popularized by this research paper by Schaefer in 2013, and he kind of tried to understand the dimensions of skills and challenge, and he found that actually the type of work that people are doing largely determines their quality or how they experience the quality of their work. So where he found that where the difficulty of the work matches their skill set, he found that that's kind of an optimal space for people to for engineers to operate on. And by the way, this doesn't just apply to engineers. This applies to all sorts of tasks. And he again proposed 7 conditions, but the last one is particularly important, right? This freedom from distractions. I think for those of you who are engineers, you probably are extremely well aware of the importance of this. And to explain this to those of you who are non-engineers, I like to borrow from another GitHub analogy that kind of considers building software like you're building this deck of cards or this house of cards in your mind, right? And anytime there's a distraction, the house of cards falls, and you've got to spend time rebuilding the concepts in your mind before you can get to the point where you can effectively synthesize the information. So an interesting point I wanted to mention is that on a recent survey done by Microsoft and Meta, they found that the number of uninterrupted coding time actually very significantly correlates by and far to enabling flow state or the quality, perception of quality. So the affective dimension that we talked about earlier, right? And the name of the research paper is called, I've listed it down there, Mind the Gap. Okay, so of course you can, so that's the challenge, right? We talked about the challenges that, you really want to allow people to get into these focus blocks. And you can do a bunch of sort of manual things to enable that, right? So for example, you can reduce meetings. In fact, at Zalando, we have this, we've enshrined that into a founding principle that we call "Don't Meet Because It's Thursday," right? So the other thing that you can do is you can actually try to automate some of that focus blocks, right? So Meta, for example, are exploring, or they played around with creating focus bots such as the focus bot, which kind of monitors a person. Of course, they don't collect this data centrally, so it operates entirely on the local system, and it operates the behavior of the developer. And where it detects that a person is getting into these focus blocks, it automatically shuts communication or distractions incoming, so that in order to protect the engineer from and keep them in the focus. Balance bots similarly, because Meta have this internal sort of Facebook-like social media, business social media system, it does automatic housekeeping, like, getting too much notifications from a particular channel, automatically kind of tone that down, etc. Okay, so that was the DevX bots, and I talked a bit about Dora earlier, right? And turns out that Dora actually has quite a significant part to play in the affective dimension as well, right? So per research from the Dora team, what they found is that improving the quality of these deployments, not only does it lead to higher code and thereby business impact and business kind of performance, it also tends to positively impact the perception of the engineer, right? So, what are some things that you can do in the app world? So, apps typically, if you're doing releases every 4 or 3 weeks, that's already kind of industry gold standard, more or less, right? You're already probably in the 90th percentile if you're doing that. But at Zalando, we tried to move that down. Well, we succeeded in moving our deployment frequency from 3 weeks to 2 weeks, and I've written a bit more about that on the Medium post, where you can find the QR code on the presentations. But yeah, so shorter release cycles is something that you can definitely aim towards. But what you're gonna find is, it's not. There's a reason why many companies are not able to attain that those 2 weeks or even 1 week cycles, and the reason because of that is because, in the mobile apps world, you have so many devices, right? It's not like you're sitting on a desktop with a particular resolution. You have all kinds of form factors. Many mobile devices have their own sort of, thin layer of thin sort of layer on top of the operating system, like One UI from Samsung, right? And you have all of these, different non-uniformity to kind of cope with. So you're going to find that you really need to invest into quality assurance and trying to do that in an automated way. So again, in summary, what we are effectively doing with shorter releases is we're avoiding the so-called drift, right? So the idea is that when you have simultaneous, a large amount of people working on code simultaneously, the shorter your drift, the less code or the less conflicts that you're going to have to contend with against all of these concurrent changes. I talked about investing into good quality practices and, of course, avoiding repetitive tasks. One point about code reviews, this often comes up at least in the companies that I've worked at, is where people tend to be quite nitpicky about things, right? And in the long run, there's probably not really a good reason to do that. You're more wanting to ensure that certain guiding principles and certain guardrail metrics are kept, and the rest of it is more or less going to look after itself, right? Another thing you can do here is to sort of put automation into place in the form of static code checks to ensure that certain of your policy guiding policies are adhered to. Okay, I realize that I'm actually maybe over time, but very quickly, or rather, sorry, I do have some more minutes. So this is the so-called theory of developer productivity that we are operating with at Zalando, or at least in apps. And now I want to talk a little bit about how we kind of translated all of that theory into practice, right? So And I wanted to do it in this way. So this is two columns. On the left, you have the trend, the strategic trend, and the right is a corresponding initiative that we drove. I talked about modularization and monorepos, build engineering optimizations, observability, etc. And systematically, we took each of these trends and roadmap them in a way, right, that the impact builds on each other, and the corresponding initiatives are like, for example, the Roadster is a code name that we use for our internal modularization project. So I'm trying to think what else I can talk about here. So of course we didn't get to all of these trends, right? There's only so much that you can do in a year. But that's also great because then that gives us a roadmap for the future. And to talk about some of the outcomes, so because of our modularization effort, I think the iOS line, which you see in orange, is really telling. The number of modules, so before we had roughly 60 to 70 modules, and now that's become 400 modules, right, in the space of 1 year. So that module explosion, here we come, that I talked about. Good. And the build observability component, we also invested quite significantly into trying to collect these metrics and trying to build useful insight out of them. And whereas before we had absolutely we were collecting data centrally, at least, from none of the bills. Now we collect data from over 40,000 bills per week. So enabling Gradle Enterprise, so like analogous to Series move from Maven to Gradle, we also moved towards Gradle Enterprise over last year. And what we found is that that improved our build times by 5 minutes, right? And 5 minutes, doesn't look like a long, but that actually translates quite significantly across a team of 120 app engineers. And we also found one example I wanted to highlight is our design system, our component library, where a very quick analysis, we realized that actually we weren't utilizing the caching in the best way. So we set that up, and with one PR, we fixed that, and that automatically improved in a 6% cache hit rate increase. Good. So those were some of the success stories. This is from the green list that you see on the right? And looking ahead to 2024, these are some of the other initiatives that we have that we want to drive. Things like adopting declarative frameworks in the form of SwiftUI and Kotlin. Actually, we've already made quite a bit of progress on this in this year. Cloud IDEs, DevX bots. So these are all areas that we are wanting to invest into. Good. I think I'm done. So thank you all for joining the presentation. I hope it was useful. You can, again, as I promised, the Medium article is linked in the QR code above. And I guess I'll be here for a while if you want to ask any questions in person. So thank you.